Section 6.3 is about probabilities with large numbers. Here are our learning objectives. The law of large numbers applies to a process for which the probability of an event A is P of A. We write the probability of that event P of A, and the results of repeated trials do not depend on the results of earlier trials. That is, they're independent. The law of large numbers states that if the process is repeated through many trials, the proportion of the trials in which event A occurs will be close to the probability P of A, and the larger number of trials, the closer the proportion should be to P of A, where this is our theoretical probability. So for example, if I flip a coin twice, right? If I flip a coin once, you think you're going to get either heads or tails. There's a 50% chance. But if I flip a coin twice and I get two tails, that kind of ruins our 50% heads, 50% tails odds. As I conduct more and more trials, say if I flip a coin 10 times, 100 times, 150 times, 1,000 times, we're going to get closer to that theoretical probability of 50% heads and 50% tails. So let's talk about a roulette wheel. I've played roulette once. I did not win. A roulette wheel has 38 numbers, 18 are black, 18 are red, and the numbers 0 and 00 are green. And we're assuming that all numbers, so all possible outcomes, have equal probability. What is the probability of getting a red number on any spin? Well, that probability is going to be 18, because I got 18 red, out of our 38 total numbers, which is 9/19 or 0.471, which is about 47.5%, sorry, 47.4%. Part B says, if patrons in a casino spin the wheel 100,000 times, how many times would you expect to see a red number? Well, I would expect that 47.4% of those 100,000 spins would end up being red. So I take 0.474 times 100,000, that equals 47,400 times. So using the law of large numbers, I would expect if I spun this wheel 100,000 times, 47,400 of them would be red. The expected value of a variable is the weighted average of all its possible values. So because there's an average, this is kind of similar to weighted mean, except now we're working with probabilities. Because there is an average, the expected value is likely to be close to the actual value only when there are a large number of events. Okay, so that's when the law of large numbers can really come into play. So for example, much as this is very similar to weighted mean, we take the value of an event times the probability of its occurrence, the value of event times the probability of its occurrence. And this can be extended to many, many more terms. Suppose that test scores on an exam have the following probabilities. 65%, getting a score of 65 has 1/10 probability. Getting a score of 75% has 3/10 probability. Getting a score of 85% has 5/10 probability. And getting a score of 95% has 1/10 probability. So from this, we can calculate the expected value or average value of an exam score for a random student. So we take 64 times 1/10 plus 75 times 3/10 plus 85 times 5/10 plus 95 times 110. We're trying to figure out their average score. That gives me 6.5 plus 22.5 plus 42.5 plus 9.5, and I would get a score of 81. So the average or expected value score would be a score of 81 or 81%. Example 4. A farmer knows that at this time of year, in his part of the country, the probability of rain on a given day is 0.5. It hasn't rained in 10 days, and he needs to decide whether to start irrigating. Is he justified in postponing irrigation because he's due for a rainy day? So let's think about this. So the odds of it raining on any day are 1/2, and it hasn't rained for 10 days. Is he justified because he's due for a rainy day? Can you really be due for a rainy day? Well, this is an example of the gambler's fallacy. So the gambler's fallacy is the mistaken high body belief that a streak of bad luck or a streak of good luck makes a person due for a streak of good luck or bad luck, vice versa, right? So like if I'm playing and I got all these scratch off tickets and none of them won, then I must be due for a winner. That's a gambler's fallacy. This is not the case. So that farmer could go ahead and start irrigation.